Section 5.5, Finding Equations of Linear Models. Basically, in this section, we're going to have word problems. And from the word problems, we are going to come up with equations. So let's take a look at one here. Page 273, number 3. The number of inmates younger than 18 held in state prisons has decreased approximately linearly from 3,147 inmates in 2001 to 2,266 inmates in 2005. Let n be the number of inmates who are under 18 and in state prisons, and t the number of years since 2000. Find a linear model. Okay, what you need to recognize here is what they've really given us is they've given us two data points. First, we need to decide which letter is going to be X and which letter is going to be Y. Typically, time is always X, and your other thing is always Y. It doesn't have to be that way. That's just the way it usually is. Okay, so then what we need to recognize is they've given us a data point right here. 3,147 inmates in 2001. So there's one data point. But you got to be careful here. A lot of people will write 2001, 3147, but recognize what it tells you T is. T is a number of years since 2000. So 2001 would be 1 year since 2000, and then we have 3,147 inmates under 18. And then right here we see our second data point. So that would be year 5, 2266 inmates. All right, that's going to be the key to these word problems. The key to these word problems is going to be reading the information and recognizing where the data points are. They're always going to give you a couple data points. Once we have our data points, then all we're doing is what we did in the previous section. Now we find the equation of the line. So to find the equation of the line, I need to know the slope. Slope is going to be 2266 minus 3147 over 5 minus 1. I'm going to need my calculator for that. I get minus 881 over 4, which is minus 220.25. Now, a typical question I might ask you, not asked in this problem, is what does that number mean? What does slope mean? Well, that slope means, notice we have number of inmates on top and we have years on bottom. So what the slope tells me is the number of inmates is dropping by approximately 220 a year. Okay, but that's not what this question asked for. We need to find a linear model. We have a choice now. We can use y equals mx plus b, or we can use y minus y1 is m times x minus x1. Do I know the y-intercept? Do I know the b number in y equals mx plus b? No, I do not, because I have a 1 in my first data point and a 5 in my second data point. My slope is not a nice number, it's got a decimal. My choice is to use the second formula then. So I'm going to go y minus 3147 equals m minus 220.25 times x minus 1. Now, we have decimals. Decimals aren't so bad. Our calculator's real good with decimals. It might not be a bad idea to simplify. Y minus 3147 equals minus 220.25x plus 220.25 when I distribute the 220.25 through and the minus sign. So y is minus 220.25x plus, I add that 3147 to both sides, I get 3367.25. So there's my equation. And then another good question I might ask you is, what's that 3367 tell you? You should recognize that that is the y-intercept, which would tell you that at time 0, which would be the year 2000, there were 3,367 inmates under the age of 18 in state prisons. Okay, number 6 on page 273. Due to a crackdown on fraudulent corporate reports, the number of restatements of facts in corporate reports has increased approximately linear from 410 restatements in 2004 to 1,793 in 2006. Let n be the number of restatements in year t since 2000. Part A, determine a linear model. Okay, once again, what we need to recognize is that we have two data points. The first is here in 2004, 410 restatements. Now be careful, t again is years since 2000. So my data points are going to look like t comma n. The first one is 2004. No, see, that's a mistake. It should just be 4 comma 410, because t is the number of years since 2000. So you can see I almost made the very common mistake there. The common mistake I'll see students do, they'll put 2004. It should just be 4. And then the next one is over here in 2006. So t would be 6. N would be 1793. All right, so I need to determine the linear model. M equals, find the slope, 1793 minus 410, divided by 6 minus 4. And again, I grab my calculator, 1793 minus 410, I get 1383 over 2. 691.5. Once again, I notice that I don't know the intercept because I don't have a 0 for either of my x values. So I think I would use y minus y1 equals m times x minus x1, except we're not using x and y, we're using n and t. So I would have n minus n1 equals m times t minus t1. So n minus, I'll use the 410, is 691.5 times t minus 4. So n minus 410 is 691.5 t minus 691.5 times 4 is 2766. Add the 410 over, n is 691.5 t minus 3176. Now notice, technically, I didn't really need to get n all by itself. But I was looking ahead and seeing, you know what? Probably going to need to anyway, because it's asking me something about the n-intercept. So I guess I decided I might as well just go ahead and figure it out. So there's my answer for part A. There's my linear model. Part B, what's the slope? Well, the slope we figured out in part A. Slope is 691.5. And what does that mean? This is the, let's see, our slope, remember, has n's on top, n is number of reinstatements, and t on bottom, t is time. So 691.5 new restatements per year. That's how, I spoke year poorly, per year. It's the number of reinstatements. It's how much the reinstatements is going up every single year. Part C, to find the n-intercept, I let t equal 0. T equals 0, I plug that in. N equals minus 3176. So that means in the year 2000, that's where we're starting, number of restatements equals negative 3,176. That really doesn't make any sense. The number of restatements can't be negative. What we have here is an example of model breakdown. It doesn't make any sense really to plug 0 in. Our model breaks down. We can't have a negative number of restatements. But that's what it would mean. And in terms of just the equation itself, that's what you get. but not really useful. Model breakdown.